Alright, welcome to Rotations Level 1. Now, in our very first example, it says find the surface area and volume of the three-dimensional shape created when rotating the semicircle below about the AB axis. So, notice we have this AB axis, which is kind of right here, and we want to rotate this semicircle about this. Well, what does that mean? Well, think about this. If we took this arc and we rotated it 180 degrees, so essentially all the way around to the other side. In fact, let me try a different color here, just one that stands out a little bit better. There we go. So all the way around. Well, this semicircle would create a circle. However, that's not the only places that we would have rotated. What if we rotated it, like very close to 90 degrees? So what you would see, if we rotate it very, very close to 90 degrees, is you would kind of see that it would be there, and we're actually kind of looking at it at a distance. What if we had rotated a little bit past 90 degrees? Well, we go through there, and as you look at this, it should become pretty obvious, like what three-dimensional shape is it creating? Well, it's creating a sphere. So if we want to find the surface area and the volume of a sphere, we're going to have to use our formulas for those things. We know that the surface area of a sphere is going to be this formula right here, 4 pi r squared. And we know that the volume of a sphere would be 4/3 pi r cubed. Now, the only thing that we have to do in order to begin this problem is simply find out what is the radius. Well, notice this line AB connects one edge of the semicircle or sphere to the other, and it goes through the center. So we know that 7 is in fact the diameter. And just remember that to go from the diameter to the radius, you simply divide by 2. So 7 divided by 2 will give us 3.5, and we simply plug that in. The surface area will be 4 times pi times 3.5 squared. Well, let me go ahead and grab my calculator. And while I won't write it down, I'll just kind of talk you all through this. You can kind of follow along. 3.5 times 3.5, or 3.5 squared, will give us 12.25 times. The next thing we do is multiply that by pi, which gives you 38.48 times that 4. And of course, our final answer should be the surface area of this sphere is 153.94, in this case, inches squared. Remember, anytime you're dealing with surface area, it'll always be your units squared. Okay, well, let's take a look at our volume. You know, the cool thing about spheres is once you know the radius, there's really no more work that has to be done outside of plugging in. So we have 4/3 times pi times 3.5 cubed. Now, if you have an iPhone, and I don't know if this works for an Android, but an iPhone, you can go to the calculator and you can simply turn it sideways. You can type in 3.5 and you should see a little x to the power of 3. If you push that, you'll get 42.875. If you don't see that, you can simply do 3.5 times 3.5 times 3.5. It's just multiplying by itself 3 times. So we now have 42.875 times pi, and that will give us 134.69, which really rounds to 134.7. And then we'll multiply that by 4/3, and the way you would want to do that is multiply it by 4, and then divide that final answer by 3. And so it turns out our volume is going to be 179.59, and in this case is inches cubed. Remember, volume will always be cubed. Alright? Pause this video, finish taking any notes that you need, and let's go ahead and move on to example 2. Okay, here we are in example 2, and it says a semicircle is rotated around its diameter. What would the volume and the surface area of the new 3D figure be given a radius of 16 inches? So these problems are designed to be hard because they don't show you the picture. However, if you draw the picture, I find that sometimes these become the easiest problems of all. So let's go ahead and draw ourselves a semicircle. And I'm not super good at those. My semicircles always look like D's, but that's okay. And so Let's see, and it's rotated about its diameter. So we know if we were to rotate it 180 degrees, it goes all the way around. But what if you were to rotate it just almost up to 90 degrees? So not quite 90, but just almost up to 90. Well, you would see it off into the distance off to the right. What if you rotate it a little bit past 90? Well, you'd kind of see the same thing just on the other side. And so when you draw it like that, it becomes very obvious that this is actually a sphere. So the first thing we want to find is the volume. So let's see, what is the volume of a sphere? Well, that will be 4/3 pi r cubed. Okay, and let's go ahead and plug in our radius, which, by the way, they give it to you straight up. You don't have to do any math. That's very, very, very convenient. Now, if you're at home and you're going to be tackling this on your phone calculator, I'm going to tell you how to do that very, very simply. So I'll just go to my calculator and I'm going to do 16. And if you have an iPhone, just turn it to the right so that it gives you the full calculator. And you should see a little x to the power of 3. And that'll give you 4,096. Now, if you don't have an iPhone and that's not working for you, you can just do 16 times 16 times 16. You multiply it by itself 3 times. So we have 4,096 times pi, which gives us 12,867.96. And then what you want to do to multiply by 4/3 is to multiply by 4 and then to divide by 3. And so what you're going to wind up with is that the volume of this particular sphere is 17,157.28. In this case, of course, it will be inches cubed, because volume is always inches cubed. Okay, now up here, I'm just going to have a little bit of space. In fact, let me even just draw a little line there. We know the surface area is 4 pi r squared. Okay, so we can write S equals 4 pi 16 squared. Now, I wouldn't expect you to know this, but 16 squared is something that's very useful to memorize. It comes up quite often. And 16 squared will be 256. So we have 4 times pi times 256 times 4, and our surface area is 1024 pi. And then, of course, you just multiply that by pi, and we get our final answer. S equals 3,216 inches squared. All right, I hope that this video helps you guys out with this level 1 problem, and I will go on to see y'all in our level 2 video.